Hello viewers, in today's class we are going to discuss an important definite integral in which Signum function is involved, right? And moreover here we'll use some important properties of inverse trigonometric functions, right? So let us start. Now here we have to evaluate this integral from -1 to 3 signum of x minus 2 tan inverse x over x square plus 1 plus tan inverse x square plus 1 over x, right? So here let us first concentrate on this term, right? Now from the properties of inverse trigonometric functions, we know that tan inverse 1 over y is equal to cot inverse y, right? And we'll make use of this property to this expression. So we see that tan inverse x square plus 1 over x can be written as cot inverse x over x square plus 1, right? So now this term tan inverse x square plus 1 over x can be replaced by cot inverse x over x square plus 1, because here tan inverse 1 over y is equal to cot inverse y, because if we take if we take 1 over y is equal to x square plus 1 over x, then obviously y is equal to x over x square plus 1. So this is our y, right? Okay, and now this integral I can be written as -1 to 3 signum of x minus 2, and now we can write it as tan inverse x over x square plus 1 plus cot inverse x over x square plus 1, right? And now again we'll apply an important property of inverse trigonometric functions, which says that tan inverse y plus cot inverse y is equal to pi over 2, right? So here if we take y as x over x square plus 1, then this term becomes tan inverse y plus cot inverse y is equal to pi over 2, right? So now our integral I becomes -1 to 3 and signum of x minus 2, and here we have pi over 2, right? And now we can take pi over 2 outside the integral, and we have -1 to 3 and signum of x minus 2, right? So viewers, now this integral reduces to this one. Now we have to evaluate this integral, and to evaluate this integral we have to make use of the definition of signum function, right? Now we know that signum of y is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to -1 whenever y is less than 0, right? Now if we take y as x minus 2, then the definition of signum of x minus 2, it becomes equal to plus 1 whenever x minus 2 is greater than 0, and equal to 0 whenever x minus 2 is equal to 0, and -1 whenever x minus 2 is less than 0, right? So now if we solve these inequalities and this equation, then we have x greater than 2, and from here we have x is equal to 2, and from here we have x is less than 2, right? Okay, so now let us see the limits of integration, right? See, here we have to integrate from -1 to 3, and here we have x is equal to 2. So x is equal to 2 is the point where we have to break the limit, right? So now this integral that is minus 1 to 3 signum of x minus 2 can be it can be written as a sum of two integrals, right? That is I1 plus I2, and I1 is from minus 1 to 2. I1 is from minus 1 to 2, and here we have signum of x minus 2 dx plus, and the second integral I2 is from 2 to 3, right? 2 to 3, and here we have signum of x minus 2 dx, right? Now we have to evaluate these two integrals. So now we see from this definition that when x lies between minus 1 and 2, right, that is when x is less than 2, because whenever x belongs to minus 1 to 2, we have x less than 2. So the value of signum of x minus 2 is minus 1, right? So I is equal to pi over 2, and we have minus 1 to 2, and here we have minus 1 dx. And when x lies between 2 and 3, then obviously x is greater than 2, so signum of x minus 2 is equal to plus 1, right? So we have 2 to 3, and here we have plus 1 dx, right? So here what we have done, see here signum of x minus 2 is equal to minus 1, because x varies from minus 1 to 2, and obviously x is less than 2 in this interval. So we have minus 1 for signum of x minus 2, and here when x varies from 2 to 3, then obviously x is greater than 2. So for signum of x minus 2, we have plus 1, right? So now we have two simple integrals, and this is pi over 2, and this is minus 1, and integral of dx is x. So here we have x minus 1 to 2, and here we have x, and limits are from 2 to 3, right? So now we can simply find out these two expressions. So we have 2, then we have minus 1, and then here we have 3 minus 2, right? And this is pi over 2, and this is minus, and 2 plus 1, and here we have 3 minus 2 is 1, and this is pi over 2, and this is minus 3 and plus 1, and this is pi over 2 times minus 2, and 2 get cancelled, and we have minus pi, right? So viewers, the value of this integral is equal to minus pi, and this is how we solve this integral.